Now take a look at this problem. It says find a parametric equation that defines the curve. So if you look at this one here, notice this one's circular. So anytime we start looking at these circular paths, think of sine and cosine. Okay, so my x could be sine of t, and my y could be cos of t, or vice versa. So if I want to pick my x, I can say x is equal to cos of t, and y is equal to sine of t. Now again, keep in mind here that if I just picked one for these, that I would get this circle of radius 1. Oops, I went beyond it. And that's not what I want. But I do want my x to be 1 here. So I keep a 1 for my cos t. And then notice for my y value, when I go up to pi halves, I'm going to want that to be 4. So that means, and it honestly is this simple. So what I mean by that is this here is just going to be 4 sine of t. And that'll do it. So these circular ones are actually pretty nice when it comes down to just coming up with the parametric equations for this. And let's say now this wasn't 0 anymore in the middle here. Let's say that was -3, 4. Ooh, what do I do then? What I would do then is think about my x value. So my x value is starting at -3. So all I would do is this. Now I actually just shifted this curve to that place. And that's what's nice, because think about it, this is my x value, and instead of this being 0 where I want it to be 0, it's now going to be -3 where I want that to be. So that's going to be my new center. So honestly, they're that easy to change once I get into these problems. It's just that simple. A nice straight transition. That's what I kind of liked about them. So these parametrics for the circles are actually really nice. So anyways, let's get back to this problem here. So here is my parametric equations, but now we have to talk about orientation, and we have to talk when we're starting, so our parameters for this. All right, so the orientation, let's see if that's in the right direction. So the way to find that out is you just plug in some values. So where is t equal to 0 at? So then for my first one, I would get for my x value, I would get a 1. And then for my y value, I would get 0. So that's nice. That's exactly what I was looking for. So I'm starting here, it looks like. Okay, now I got to make sure I'm going in the right direction now. So now I'm going to pick t equals pi halves. So when I pick pi halves, I know my x is going to be 0 because the cos of pi halves is 0. And then my y is going to equal 4. So it's going to be 0, 4. So now I'm going to find the point 0, 4, and it's right there. So I am going in that direction. But I'm starting here at 1, 0. And I don't want to start at 1, 0. I want to start at 0, -4. So what I can do in order to accomplish that is I can just back up a little more. So maybe not let my t be 0, but my t should be actually -pi halves. So this is what I'm going to get. So this would be a nice parametric equation. These would be my parametric equations with my parameter t here at the bottom. So let me just put that all together for you. So here's the answer down here. And this would be a completed answer. And again, do not forget your parameters on t. That's a big one there. So you lose points for that. So there's our answer for this one here. And just remember one thing here. That remember, when I was on the x, I needed a 1 away. So that's how I get my 1 away. And when I was on the y, I had a 4 here because I needed to get 4 away from the center. Okay, so those are nice, easy ways to see how that all works together. So there's your